What's up guys, welcome to the channel. It is your boy Paladin Saffron, and in today's episode I'm basically going to teach you the most simple way to create a linked list in C++. So as you can see, I have this blank program set up. So basically what you want to start off with is creating a structure. This for the structure, we're going to call it structure link node. We're going to open it up. And then in the link node, we have to give it some sort of a value. So we'll just go ahead and say, we'll do names. So string, and then I guess data. This is the data in the node. And then obviously you need to create a chain of these link nodes. So you're gonna hold a pointer to the next node. So it's gonna be basically link node. Now I like to call it node pointer, or you could call it whatever you want. To make it simpler, you could just say pointer. Perhaps you want a constructor as well, so we'll make one real quickly. And anytime you make a link node, you should have a head and a tail. Basically, but I'm just gonna make them global constant. So global constant, I'm gonna just say link node link head and link node link tail, whatever. So there's two ways to make well, there's many ways to make linked lists, but two of the basic ways is singly linked list or doubly linked list. So basically a singly can only traverse in one direction from the beginning to the end, and doubly can be traversed forwards and backwards. So if you want, we can make this a doubly linked list. Say link node, I guess actually I kind of like this backward and forward. This is usually how I roll it, and anytime you create this, you want to just go ahead and say forward equals null pointer and backward equals null pointer. Let's go ahead and do this just to make it seem a little bit cleaner, whatever. And then obviously you can do constructor to link node. And for this one, we're going to initialize the data in it. So it'll basically be link node, and we're going to pass a string value. Oh, forgot this isn't Java. Then we're going to say this dot data equals, or instead of that, we'll do data equals value. And then once again, forward equals null pointer and backward equals null pointer. So basically you have a link node structure, and now you also have a global constant. We could turn this into a class, but I don't. This is just very generic as how to make it. But so now let's create a link node. So we'll say link node link1 equals new link node whatever, right? Did I do this right? Oh yeah, so because of the structure, we want it to be a pointer, and then we'll say link1 data equals what should we name it? Intelligent. Not sure, just give it some sort of value. And when we created this, this already executed, so this isn't connected to anything else. But basically, let's go ahead and make these null pointers too. Might as well null pointer, because it'll be initialized later on. But now what we want to do is create a link node. We could say link2 equals new link node, and we could basically say this is CLion, because this is the text editor I'm using for C++. Well, actually, just to make it easier, we'll say this is C++, and we'll say this is Java. So we'll do languages. And then once that's created, this is we initialized it with the constructor, and this is how we initialized it, just like by calling the variable itself. But you could use functions, you could use methods, all that. So now we need to connect them. So the way to connect it is link1 forward equals, we're going to point to link2, and then link2 forward, because it's at the end of the list, is going to be no pointer, which it was already no pointer, so there's no point in re-saying that. But since that's forward, we're going to, now we have to traverse backwards, so link2 backward equals link1, right? So I'm going to teach you guys, I'm going to just say set the chain links manually, why not? But you could create functions for this, but I'm going to show you guys a function to traverse this. So just to recap, we created a link node and we pointed its forward pointer to the next link node, and then that next link node's backward pointer points to link 1, and all other link nodes should be all other link node pointers should be nulled because it's just these two. But we can go ahead and make a third one too, just to make it easier. I'm gonna just say link node link3 equals new link node, and we'll say Python. So there's many ways to set this up. Those are just a couple ways. And then we can say link to, well, this one I rather put it in this way. So link1 forward equals link2. The link2 forward equals link3, right? And the link2 backward equals link1. Or to make it simpler, you could kind of go from the backwards. So link1, well, link3 backward equals link2. So imagine it kind of like this is link1. So we go to the first link, then we move to the second link, then the second link we move to the third link, and then we reach the end. I could say no pointer. Well, that doesn't make sense, I'm sorry. Link3, and then we're reach the end basically, and then we go backwards. So link3 backward equals link2, and then link2's backward equals link1. And then just to go even step further, we could say link head equals link1, link tail equals link3. Now let's create a function to print this stuff out. So basically you're gonna have to say function prototypes, and we'll say void print link list, whatever, and basically we're passing a link node, which is going to be the start. I guess we really don't need to print that in because we have global constants, but you could pass in the link node as the start of the list. But basically what it's going to look like is while link head forward does not equal null pointer, I'm going to say print, so cout link head data, and then we're basically just going to put a space in between. Yeah, so oh no, another easier way is just saying while link head is true. So while it's true, and then we have to move to the next one. So link head, oh shoot, we actually need something that a temporary value to traverse. So we're gonna say iterator equals link head. So while iterator itself is true, we're gonna print out the iterator's data, and then we're going to move iterator to the next one on the list. So equals iterator forward, and then I could say print forward, print in order. Let's just say that. So here we go. That looks good. So basically we'll go back to here and we'll test it out. So did I put that in the wrong spot? Yeah, function prototype is correct. We'll basically print the list now. So print the list, print in order, and we'll see what that does for us. So as you see, the links are connected to each other now. Just to make it seem, fix it up a little bit. Instead of that, I'm gonna just say new line. Now there we go. So as you can see, these are all the items in the list. So let's go ahead and make some additional functions. So let's say this is void, or we'll say create link. No, not create link. Let me show you guys the remove. So this is how you remove items from a link list. So we'll say void remove, and we'll say, so we need a value. So we're gonna pass a value, so string value, string value. So remove an item from the list. Whoops, typing a little bit too fast right now. So remove. So now we need to iterate through the list. So let's create a iterator. So link node iterator. We'll just call this one it equals link head. Then we'll say while link head is true, right? Oh, I'm sorry. What I meant to say was while link head is true, loop through the list. And what we're gonna do is if it data equals value. So we found a value, so now we need to remove it. So remove the item. So this is, I can already see some problems that it's going to arise, because obviously what if you have the same value in different spots in the linked list? Say I had C++ written again. Well, the way this program is going to work, it's going to start from the very front and it's going to go until it sees this value, and then it's going to remove the value, reattach the links, and then exit. Now you can make functions and specify them as specific as you want, but this is just a generic concept. I could even do it from the backwards if I wanted to. So say I wanted it, I could say link tail, and then I can move backwards in the list. It really, that's the benefits of having a linked list. So let's go ahead and remove the item. So basically what we want to do is create a temporary node. So we'll say link node. So what we're going to do is we're basically going to delete that value. We're not going to, we're going to delete that memory. We're not going to, we're basically not going to do anything else with it. We're just going to remove it. It's not like we're going to pop the value off. I could pop the value off if I wanted to. Actually, why not? Why not just pop the value? So let's say string. So remove, so we'll just say pop. So link, so if it equals data linked node, well, we don't need that. We would just say, so we'll create a temporary string. So string temp equals, if data equals, so we want to say string temp equals data, right? Then we want to reattach the links. So to do this is we're basically going to say it backwards. So what if it's first in the list? Let's go ahead and try to solve for that. Let's see. If it equals link head and it data equals value, we're basically gonna say that a string temp equals it data, right? And then link head equals link head forward, and link node, we'll call this removed link I. Before we do that, we have to say removed link equals it, but this is if it's the front one. Removed link equals link head itself equals the next one, and then link head backward equals no pointer, and we're just going to go ahead and say delete move link, and we're going to return temp. Else if it's if front value is found at the front of the list, I'll say Control X, value is found at the front of the list, we'll say if value is found somewhere in the middle of the list. So once I'm going to say string temp, we need to make a link node again, so link node removed link string temp equals temp data. Awesome. So removed link equals it, yeah, so if this equals that, then do that. Also if data equals value, yeah, so if data equals no, I'm just gonna keep it as an if. So let's see this. So like created the temporary value, store the value, remove link equals it, so it, now keep up with me here, so it backward, right, it backwards pointer, its backwards nodes front forward equals its forwards pointer. Alright, does that make sense? And then it forward, its forwards backward pointer equals its backward. Then what we're basically going to do is delete temp, or delete remove link, and we're going to return temp. Alright, looks good. It's looking about right. Let's go ahead and save this. So this loops until it returns. And now I see the reason for an else if. Else it equals it forward. So let's see if this works right here. So we're gonna basically pop. So we'll say printer list, and let's just say pop. Yeah, so pop. Let's pop Java, and then we'll print in order. So yeah, inline, and let's see what that does for us. As you can see, the link has removed itself. Now there's only 2 items left, and what we can do is how you should always end. Program is basically clean up memory. So to clean up memory, you basically want to say delete, I guess, link 1, delete link 1, delete link 2, delete link 3. But I think link 3 is already deleted at this point. Is it not? I'm not sure. I guess I could delete head and delete tail. Or, sorry. Link head, link tail. And I guess that's pretty much it. Let's go ahead and run that. And yeah, seems like it's doing what it's supposed to. Yeah. Oh, and I think what we need to do is eventually what we would have to do is update the link tail and link head as you know, we do it. But this was just a very basic idea of how linked list works. So I hope you guys enjoyed the video, and if you guys want to see more videos like that, leave them in the comments and let me know what I should cover next.